Now, what we want to look at is solving a radical equation. We're going to mainly focus on the radical equation, meaning a square root, okay? Now, it's going to be very similar to the absolute value in the sense of I'm going to isolate that square root. I'm going to get rid of the square root. Now, that's where it gets a little bit more tricky. Not that it's any more difficult, it's just that the math, it takes more for me to get to my answer. Because when we had an absolute value, we created linear equations versus when we get rid of a square root, we're going to create quadratic equations. So that means I'm going to bring back in factoring, maybe the quadratic form. So it just gets a little more complex, if you will, but it's not anything that we haven't done so far. So let's look at an example of what that might look like. Okay, let's say we have 3 square roots of x plus 3 minus 5 equals 10. So I'm going to start off and I'm going to isolate my square root. So I'm going to move that 5 to the other side. I have 3 square root x plus 3 equals 15. I'm going to divide by that 3. So I've got the square root of x plus 3 equals 5. Now that my square root is isolated, I'm going to now get rid of that square root by squaring both sides. Now this one is going to be pretty easy because when I square a 5, I don't have any letters over there or variables. I only have a number. So when I square 5, it's pretty easy. I get 25. Okay? We'll see some in a minute that aren't as easy, we'll say, or as short. All right, so now that we have x plus 3 equals 25, we're going to continue to solve. We're going to subtract that 3, x equals 22. So I have one more step when we look at a square root or a radical. I need to make sure that it works. So I need to go back up to the top and I'm going to check my solution. What we're checking for is to make sure that it actually is a true statement. So I'm going to plug in, substituting 22 where the x is, and make sure that I actually get what I'm supposed to be. So the question is, do I really equal 10 in the end? Okay, so let's see. 22 plus 3 is 25. The square root of 25 is 5. 5 times 3 is 15. 15 minus 5 is 10. So it checks out. 22 is our solution. Okay? So you're thinking, oh, that one was pretty easy. And that one was easy. So let's do another one and make sure we can do one that's a little bit more complicated. Okay? So let's start off with the square root 2x minus 1 plus 2 on the outside equals x. All right, so starting off the same, we want to isolate that square root. So I'm going to move this 2 to the other side. So I've got that. Square root of 2x minus 1 equals x minus 2. Now that I have isolated that squared term, or excuse me, the square root term, I'm going to square both sides. Now, here's where it gets a little bit tricky. When I come over here to square this term, I have to square it, meaning that I have to write it twice and distribute it out. So really, I'm going to end up with x squared minus 2x minus 2x plus 4. So what I'm really going to end up with, let's combine those like terms, is x squared minus 4x plus 4 on that right side of the equation. the most common mistake people make is they try to take that 2 and distribute it. No, when it is squaring, I have to write it twice and distribute it out. Okay, so now that it's a quadratic and I've got all these x's, now is when I'm going to solve this quadratic in a more, I guess we'll say, lengthy method, right? So when I've got a quadratic like this, I need to set it equal to 0. So I need to move that 2x and that 1 to the other side so that I can 0 out here. So I'm going to be left with x squared minus 6x plus 5. Now I've got some options. I can either factor quadratic formula. I'm going to go ahead and factor it. So I'm going to say what multiplies to 5 and adds to negative 6. So I'm going to get x minus 5 and x minus 1. Okay, so I've got x minus 5, x minus 1, that's set equal to 0. Remember, when we solve by factoring, we're going to set each of those factors equal to 0. So I'm going to have x minus 5 equals 0. I'm going to have x minus 1 equals 0. I would finish solving those to get x equals 5 and x equals 1. Now, before I can just start boxing in answers, I need to go back and I need to check each of these solutions. Remember, we're checking to make sure that they actually work. So the first thing I'm going to check is I'm going to check, let's say x equals 5. So I'm going to plug in a 5 here. So I'm going to have 2 times 5 minus 1 plus a 2 equal 5. So let's see. 5 times 2 is 10. 10 minus 1 is 9. Square root of 9 is 3. 3 plus 2 is 5. 5 equals 5. Good. I can box that one in. All right, so let's try 1. So this time we're going to check x equals 1. So 2 times 1 is 2. 2 minus 1 is 1. Square root of 1 is 1. 1 plus 2 is 3. 3 does not equal 1. This does not work. This is what we call an extraneous solution. It's called extraneous because it's extra in our answers. We solved and we got this answer, but it's extra because it doesn't actually go back and plug in. So I have to make sure that I'm checking my solutions so that I know if it works or if it was really what we call an extraneous solution. So we've got the square root method, which sometimes it's pretty straightforward, pretty nice and easy, because when I go to square the term here in this step here, whenever I go to square my term, if it's just a number, it's going to be pretty nice and easy. But if I go to square my term and it's a variable over there, then it gets a little bit more lengthy. The process is still the same though. I want to isolate my squared term, or isolate my square rooted term, excuse me. I want to square both sides, and then I want to solve and check those solutions.